Hello and welcome to another math video lesson with Mr. Thompson. This is lesson 4.4 on what's called gradient. Alright, now gradient has to do with lines. Obviously, we've been talking about graphing lines on the coordinate plane, and one of the most important things about lines is the gradient. Okay, so if we draw our coordinate plane here, we can draw a bunch of different kinds of lines. Here's a nice friendly purple line. Pretty standard, nothing special. And if we draw this green line, you'll notice some things that are different between these two lines. One of the most striking things is one line is steeper than the other. That green line that I've just drawn is less steep. Alright, if you were going to walk up either of these two lines as sort of hills, you'd rather go up the green one, right? A little easier. Okay, here's a blue line that is very, very steep that you would not want to walk up. You'd probably need more of a ladder or something like that. We could also draw this red line, which is actually going down, okay, which offers a whole new concept. Okay, so gradient is what we're talking about here. We're talking about the steepness of a line. Okay, now gradient is also sometimes called slope. So if I slip up and say the word slope, don't get confused, it's just the same thing as gradient, okay? Now, steepness, you know, it's easy enough to say that one line is steeper than another, or not very steep, or one line goes down instead of going up, or whatever, but that's not very precise, it's not very exact. So we use gradient, and gradient, when we talk about gradient, we're talking about a number, okay? So it's an exact number that tells us exactly how steep a line is, okay? Now, a few things to note about the number and how the number relates to how steep a line is. A bigger number for the gradient means that the line is steeper. So that would, of course, imply a smaller number means that it is less steep. Now, there's one little thing that can get a bit confusing with this concept, and so I'm just going to tell you how to make sure you've got it the right way around right now, and that is that a smaller number is a number that is closer to 0. Okay, that might seem obvious, but it can get a little tricky sometimes. Okay, so the number 2 is obviously closer to 0 than the number 5, say. Yeah, just keep that in mind. We'll come back to that. Okay, especially when we start talking about negative numbers, and that's where that smaller number issue gets a little tricky. If a line has a negative gradient, that means the line is going down. So you can see my color coordination here. The bigger number is in the blue. The writing is in the blue. This blue line would have a bigger number. It's steeper. The green line is less steep. It's going to have a smaller number. And the red line goes down. It's going to have a negative number for the gradient. Okay, let's look at and of course for negative numbers, the bigger and smaller concepts still apply. So again, we'll come back to that here in a second. Let's talk about how to calculate gradient. Okay, there's a formula for calculating gradient, and it goes like this: gradient equals rise over run. If you don't already have that memorized, you're going to want to work on that. Write it down. Remember that. Okay, gradient equals rise over run. For example, with this line here that I've drawn, okay, we want to figure out the rise and the run. So what are the rise and the run? Well, the rise is the amount that a line goes up, and the run is the amount that the line goes over. So we're going to start over here, and the amount that it goes over is like this, the run. Okay, it goes from over here, and the line moves to over there. Okay, it's up above there, but the run is the horizontal change in position from one end to the other. So we go from here to there. That's our run. Okay, the rise goes from where it started below up to the top. So from here to here is the rise. Okay, that's the amount that the line goes up. All right, and we can count these little boxes on my screen here for the run. We count those boxes. There's 10 boxes, and the rise goes up 5. Okay, so we can put those into the formula. We can figure out the gradient. The rise over the run would be 5 over 10, right? We reduce that fraction and we get 1/2. Okay, so the gradient for this line is 1/2. All right, and if you think about it, if you look at this line, every time it goes up one, right, up one box, it goes over two. Up one, over two, up one, over two. So it makes a lot of sense that the gradient is 1/2, 1 over 2. The rise of 1, every time it rises 1, it goes over 2. Okay, let's look at another line. Okay, this one's a little steeper, so by our previous rules, we should know that this is going to have a bigger number, right? The run turns out to be the same, right? We already have the run, but the rise is a little bit more. It goes up 3 more, so it goes up 8. The rise is 8. So our gradient is going to be 8 over 10. That reduces to 4/5. Okay, and 4/5 is bigger than 1/2. But the easiest way to compare between these two numbers is using those unsimplified numbers, 8/10 and 5/10, and of course 8/10 is more than 5/10. So it is bigger, and it was steeper, so we were right. Let's do one more little example. This one has the same rise as the first line. Okay, same rise but a smaller run. The run is only 3, and the rise is 5. So the gradient for this one is going to be 5/3. Okay, that doesn't simplify, so that's the answer for that one, the gradient. And it is bigger. 5/3 is bigger than 8/10 and 4/5 and 5/10 and 1/2. It's the biggest one. It's the only one that's bigger than 1, right? 5/3 is more than 1. So that's our biggest slope so far, our biggest gradient so far. Okay, let's talk about negative gradient. All right, remember these are the lines that are going down. So here's a line going down. Okay, and we can look at the run. The run is how much it goes over, and it goes over 10. Same as the couple of those last lines. All right, but here our rise actually goes down, right? It goes down. So it's not really much of a rise. It's a little bit more of a fall. When we have a rise that goes down, we describe that as a negative number. It goes down, so it's risen -5. It's gone down 5. Hasn't actually risen at all. So we calculate that gradient. We say that the gradient is -5 over 10, which is -1/2. Interesting thing is that 1/2 means it basically has the same gradient as that other line with 1/2 on the previous page over here. This line had a slope of 1/2. So these two lines actually have the same slope, just that one is going down and one is going up. Okay, one is negative and one is positive. So if you were walking up either of these two lines, if you were going up the first one, it would feel the same as going up this other one, but you'd have to go backwards. Which brings me to an important point. When we calculate gradient, we always go left to right. Okay, if we'd have calculated starting here and said our run goes that way, and therefore we have a rise, right? We could have had the run this way and then a rise of 5, and we might come up with a positive number. But we always go left to right and top to bottom. Okay, just like reading a page of a book. Okay, always left to right, top to bottom. Let's look at one more example of a line going down, and here I've drawn a steeper line, so we expect it to be a bigger number, right? Okay, and again, this is where it could get a little tricky. The run is the same, we get a run of 10, but the rise goes down 2 more. So we have a rise of -7. Our gradient then is going to be -7 over 10, okay, which doesn't reduce, right? Now, if we look at these two numbers, we thought this was going to be a bigger number, right? But -7/10 is below -5/10. It's further down. It's less than. It's lower, right? It is lower, and it is less than. But is it steeper? The answer is yes. Okay, so this is where it gets a little tricky. It's a lower number, but it is bigger. Okay, and the way that we define bigger and smaller numbers is, as I said before, a smaller number is closer to 0. Which one of these numbers is closer? 5/10 is closer to 0 than 7/10, so it's a smaller number. Now 7/10 is less than 5/10, right? But it is actually a bigger or larger number. We wouldn't say it's greater than, but we would say that it's bigger. If that's a little bit confusing, you can think about money. If you owe somebody money, would you rather owe them 7/10 of a dollar or owe them 5/10 of a dollar. You would rather owe them 5/10 because that's a smaller debt. That's 50 cents as opposed to owing them 70 cents. So you can think about that. The smaller debt corresponds with a less steep line. Okay. All right. So last thing to talk about here is horizontal and vertical lines. They're a bit of a special case, each one of them. Let's start with horizontal. Okay. Here's a nice little horizontal line. It's got a run of 5, easy enough, but there's no rise. Okay, so we say the rise is 0. Okay, it hasn't risen at all. So when we go to calculate the gradient, we get a gradient of 0 over 5. Okay, which of course 0/5 is just 0. It's no fifths at all. 0 over anything is 0. Okay, so now, if you think about it, that's always going to happen because any horizontal line is always going to have a rise. Okay, and see, I've made a little mistake here. Stick that in. A rise of 0. That's always going to be the case, so we can just make a rule and say that horizontal lines always have a gradient of 0. Okay. What about vertical? Is that going to be the same? Here's a nice vertical line. Okay, this one has a rise of 5. Okay, it does have a rise, but it doesn't have a run, no run. So the run in this case is 0. Okay, so when we go to calculate our gradient is 5 over 0. 5/0, well, you can't have 5/0, right? It doesn't make any sense. It just can't happen. If you plug that into a calculator, it'll tell you it's undefined. It can't do it. It's just one of those things that in math, it's just not allowed. Okay, so vertical lines, and this is always going to happen with vertical lines, the run is always going to be 0, okay, because it's never going to go anywhere. That's the whole point of a vertical line. So we can make a rule that vertical lines have undefined gradient, okay, and that's that, always. To review, gradient is the steepness of a line. A bigger number is a steeper line, and a smaller number is a less steep line, and that means the gradient, the number is closer to 0, right? A negative number has the line that goes down has a negative gradient, right? We calculate the gradient using the formula rise over run. Okay, negative again is when it goes down. And even when there's a lesser number, a lower number, that means it's actually bigger if they're negative. So that's the steeper line. Okay, and remember that horizontal lines have 0 gradient and vertical lines have undefined gradient. All right, that's it for now. See you next time.